Welcome back. Today we're going to continue our conversation with simplifying algebraic expressions with this part, which is expanding algebraic expressions. So basically what we're going to do in this case is we're going to simplify through using the distributive property. So let's go ahead and make sure we review the distributive property and make sure that you understand how to use this property. Let's say I have I'm going to have a party. I'm going to have 5 pieces of candy I'm going to hand out to the people at my party. And at my party, I'm going to have 3 boys and 2 girls that are going to attend the party. So if I need to figure out how much candy, I'm going to figure out, well, 5 pieces of candy go for each of the boys. And there are 3 boys. So I'm going to do 5 times 3. I'm going to add that to the candy that goes to the girls. There's 5 pieces of candy for each girl. And so when I go ahead and solve this problem, I'm going to have 5 times 3 is 15, plus 5 times 2 is 10. And when I combine these, I'm going to get 25. So I would have a total of 25 pieces of candy that would need to be provided for all of the people at my party. Now, you may be thinking to yourself right now, but wait, couldn't I just do 5 times 3 plus 2? Wouldn't it have been so much easier just to make this 5 times 5 and get 25? The answer is yes, it would be easier. However, that only works when you're working with numbers. Now, numeric terms. What happens if you're working with algebraic terms? What if I'm going to have 5 pieces of candy, and I'm going to give this to the boys and the girls at the party. So let's say I don't know how many boys are going to be here, but I'm going to have this many boys, and I'm going to have this many girls. And I don't know how much of each. Well, what I do know is I'm going to have 5 pieces of candy per boy, and I'm going to have 5 pieces of candy per girl. And sometimes that's as far as I can go because I don't know quite yet how many boys and girls there are. I don't even know if there's the same amount. Therefore, I can't add the number of boys and girls together. So I'm going to have them 2 separate things until I know. That is why we use the distributive property, or one of the reasons is because sometimes we're dealing with algebraic terms and we simply don't know what the variable means. Therefore, we're going to have to we can't combine terms unless they're like terms. Okay, so we got quite a few of these to go through, so let's go ahead and get started. Let's say, and we're going to just expand each expression. Let's say I have 2 times 3y plus 4. Well, again, in this case, I'm going to take 2 times 3y, and I have 2 sets of 3y's, which would end up getting me 6y's. Again, I don't know what y is, but I know I have 6 sets of them. I'm going to add it, because there's an addition sign. 2 times 4 is 8. I cannot combine these because they are not like terms. Therefore, that is as simplified as it can get, and that is my answer. You're going to find that in most of these problems, they're going to be very, very similar in the way we solve them. Just sometimes the numbers can tend to get wow, that's interesting. All right, let's just go ahead and put that in there. Okay, so let's go ahead and continue. So let's say we have 1/2 now times 8m plus 6. Okay, well in this case I'm going to distribute the 1/2. 1/2 of 8m, that means I start with 8m's, I'm only going to have half of them. Well, half of 8 is 4, so now I have 4m plus half of 6. Well, if I have $6 and you get half of it, you get 3. So I have 1/2 of 6 is 3. I cannot combine these because they are not like terms. Therefore, 4m plus 3 is my answer as simplified as it can get. Much like the last problem, except for in this case, we have a fraction involved. Let's continue this, but now we're going to go throw in a subtraction sign. So this time, let's have 1/5 times 10x minus 25. Now, in this case, you may think, 1/5. I understand that half of something. I understand how to do half of something. I don't know how to do 1/5 of something. Let's further investigate half of something. Basically, if you're taking half of a number, aren't you just dividing it by 2? If I have $8 and I get half of it, aren't I just doing $8 divided by 2? Isn't this kind of like if I'm multiplying by a fraction, I can divide by its reciprocal? So if I'm multiplying 8 by 1/2, isn't that the same thing as taking 8 divided by 2? It is. It's exactly like that. So if I have 1/5 times 10, that's the same thing as doing 10 divided by 5, which makes it so much easier. 10 divided by 5 will get me 2x. Since I have a subtraction sign, I'm going to bring that subtraction sign down. 1/5 of 25 is like 25 divided by 5, and that gets me 5. They're not like terms, therefore that is my final answer because I cannot combine them any further than that. So again, the big difference is now we have a subtraction sign included, and you treat it the exact same way, except for the fact that we have subtraction now. All right, let's look if we have, what if we have 2/3 times n minus 9? Now this one becomes a little bit more complicated. Now if you're really good at what you're doing, you can do this in your head. Some of you may not be able to do this. Now the first part's really easy. If I have, again, I'm going to distribute the 2/3. If I have 2/3 of n, I don't know what n is, but I have 2/3 of it. Simple enough, it's just 2/3 n. And since there's a minus sign, I'm going to bring the minus sign down. Now, the next part is not as easy. I have 2/3 times 9. Now, if you can do it in your head, wonderful. If not, you may want to write it off to the side. So I could do 2/3 times 9 over 1 because 9 over 1 is the same thing as 9. And I'm going to go ahead and simplify. The 3 and the 9 cancel out. We divide them both by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. And then I multiply and I get 6. So I'm going to have 2/3 n minus 6. Well, if we look at the work there, could we have done this in our head? Could we say, well, I know I'm going to divide by 3. I'm dividing by the denominator because I want to flip it. So couldn't I divide by 3 then multiply by the top number? You could do it that way. It will always work out that way. If you're multiplying by our fraction here, you can think of, I'm going to first divide by the denominator and then multiply by the numerator. Now, I would caution you, only do that when the denominator is a factor of the number we're dealing with. Like 3 is a factor of 9. Therefore, it would go in nice and evenly, and we wouldn't have to deal with any remainders. That's why we were able to do that. All right, let's continue. Let's make these progressively a little bit harder. Number 5. Now we're going to deal with decimals. Now, some of you like decimals better than fractions. I personally like dealing with fractions, but that's just me. Oops. We'll make this w plus 4. So we have 0.4 times w plus 4. Again, even though it's decimals, we're still going to do the exact same thing because it's the distributive property. So we're going to distribute the 0.4 times w. I don't know what w is, but I do know that I'm going to take 4/10 of it. So I'm going to put 4/10 w. Since there's addition, I'm going to put plus down here. Then 0.4 times 4. Now, maybe you don't know what this is, so you could go over here and just write it out. And I'm going to see that 4 times 4 is 16. One number to the right of the decimal, therefore the answer is like that. Some of you are able to do this in your head. Either way is fine with me. I'll probably write it out to the side just to help those who want to see visually how we're doing this. So I end up with 0.4w plus 1.6, and that is our final answer. We cannot simplify it anymore because they are not like terms. Okay, got a couple more. Let's look at what if I have number 6. What if I have a whole number, a whole number times 2b minus 2, but then I'm going to go ahead and throw in a minus 3b. Okay, well, we're going to stick with what we know. We're going to first deal with the distributive property, get that out of the way. So I'm going to do 5 times 2b, which is going to give me a total of 10b. And then I'm going to put my minus sign down, and I'm going to go ahead and 5 times 2 is 10. And then I'll bring down the minus 3b. Now, me personally, I like using a method called LCO, where I'm going to leave, change, opposite. Basically, I'm going to make this subtraction into addition and change the positive 10 into a negative 10. I'm going to do the same thing over here. I'm going to leave, change, opposite. The negative 10 stays the same now. The subtraction becomes addition, and the positive 3b becomes negative 3b. Why do I do that? Well, I do this because now the problem becomes addition, and it's commutative. And if I want to make it 10b plus negative 3b plus negative 10, I can do that. And now I can go ahead and I can group. I can say, well, these are like terms, and 10b plus negative 3b would basically be 10 plus negative 3, 7b, and then plus negative 10, which I'm going to write it as minus 10. Both of them mean the same way, but we should get in the habit of using subtraction whenever possible with our final answer, so we don't have to have basically a subtraction problem with a negative sign or an addition problem with a negative sign. We just limit it to one sign if at all possible. So 7b minus 10 would be our final answer here. And now we can't get any more simplified because we have now dealt with all of our like terms. Okay, getting to the end, we're just 2 away. So let's go ahead and make, for number 7, what if I have negative 3 times 2y minus 6? Again, I'm just going to use my distributive property. Now, at this point, if you want to make this a plus negative, it may make it easier for you. I totally get that. I may do that myself just so I don't deal with a lot of negative signs and subtraction. So I'm going to go ahead and do negative 3 times 2y, which is going to get me negative 6y, and then negative 3 times negative 6, and that's going to be a plus sign, is actually going to get me a positive 18. And so my answer, instead of being minus negative, is just plus positive. So I have negative 6y plus 18. And that's the final answer to that. Again, I like doing that. I like doing the LCO and changing my subtraction problems into addition. It just makes everything very clear. Everything is assigned a sign, and there's no confusion that way. But that's just me. Here is our final problem. It is a bit of a doozy. All right, let's go ahead and do negative 4 times x plus 3y plus 3 times 2x minus 5y. Okay, I'm going to use some different colors so we don't get ourselves too confused. If I do negative 4 times x, I'm going to get negative 4x plus negative 4 times 3y is going to get me negative 12y, negative 12y plus. Then I'm going to go ahead and do my next set. Let's go ahead and do 3 times 2x is going to give me 6x minus 3 times negative 5y, which will get me negative or minus 15y. All right, now I can go ahead and begin. I'm going to go ahead and do this. I'm going to go ahead and make this a plus negative. I've not changed anything. I've just made it into an addition problem. Now I can go ahead and begin thinking, combining like terms. I can combine the negative 4x plus the positive 6x, because all these are addition. I can go in any order now. If I add those together, I get positive 2x plus, and then I'm going to combine the negative 12y plus the negative 15y, which is going to get me negative 27y. Or, if you want to, you can just do 2x minus 27y. Okay, this concludes our lesson on expanding algebraic expressions. I hope this made some sense to you. Wish you luck with your problems. Have a great day.